Okay. Hello. Seeing if the stream. Okay. Hello. Hey. Cool. Looks like we're live. It might be a bit blurry. A little bit blurry. That's excellent connection. That doesn't look very good. Excellent connection. Not very good to me. We're gonna go slowest, best quality. See if that cleans it up. I don't really care about the delay. Just want to see if I can make it so it's not very blurry. Oh, that's much better. Okay. Good to go. Looks like we're good. Hey, hon. I'm back to learning C++. Okay. Cool. So I did it. Very happy. Did it.
This is called the console or the terminal window. It's basically a way to see the output of our program. So over here,
So I've got a
you can
compiler.
see the hello world message. So we're using a console application here because console applications are easier to create, especially for people learning a new language. Building applications with a graphical user interface or GUI is way more complex. So once you understand the basics of C++, you'll be ready to move on to writing applications with a graphical user interface if that's what you want, okay? Now, let's minimize this window and make a tiny problem in this code. So I'm going to remove this semicolon. Now, let's rerun our program. All right, look, this time we get a compilation error pointing to this line. So the error is reminding us that we have forgotten a semicolon. If you're starting out, it's completely normal to encounter these errors.
Hey,
Again,
yeah, it's been a
typo
while,
or
huh?
missing semicolon and so on. Don't let that discourage you. Remember, patience is the first skill of a good programmer. So if your code doesn't get
So I got a new laptop, by the way. I got a new laptop. New laptop. The problem is it doesn't have as many in like USB ports. So my camera is going to be the default camera in the laptop because that's I had to sacrifice it. It's right here. I don't have enough USB ports. APP's down. Get out of here. Oh, you got a PC now. Hey, that's awesome, Gold Cat. That's awesome, man. APB's been down for like a month, okay? But the thing is, so the game that I was working on, well, first off, the project's gone at this point. I got a new laptop, so all of that progress is gone. But I think it's a blessing. Kind of a blessing in disguise because I was using the Unreal Blueprint system. I was using the Unreal Blueprint system, and I think it's better. I think it's a little bit better if I might just learn C++. Okay? Because at least that way I'm not uh, like limited to only using Unreal Engine. I'd be able to use other game engines or other stuff in the future, right? I think it'd be better if I just learned C++. Zombie Biscuits, right? Fucking. Nah, they've been having server issues. Like their provider or something did like a migration thing, and then it was just down for literally like almost a month. It's been down for a while. Um, but I'm learning C++. I'm gonna make an APB like on Unreal, but I'm doing baby steps. So I'm watching this
compile,
video,
pay close attention to this video, see what exactly I'm typing, compare it with your code. I promise,
and I've got
if
a
you pay close
compiler on my
attention,
phone.
you'll be able
So
to solve issues on your own.
uh,
So let's fix the issue.
I got a notebook,
All right, let's
I
move
got a
on to the
pen,
next
and I got a
step.
compiler so I can practice. As he goes, I go. Right? That's the goal. That's the goal. That is my goal. My goal.
Now, going forward, I want to change the colors here, and I wanted to show you how to do that because a lot of people ask me about the themes I use in my videos. If you're not using CLion, feel free to move on to the next
Oh,
lesson.
you downloaded GTA?
So,
Nice, man. That's
on the top,
nice. Nice. It's a
we
very
go
fun
to the
game.
preferences
It's a
panel.
very fun game. I love GTA.
Then under appearance and behavior, we select appearance. Now over here, you can see the themes that are installed by default. We only have 4 themes, but we can get more themes by clicking on this link. Now on this page, I'm going to sort this list by
This is all for
Dracula
Sea
themes.
Lion. I don't really
Good.
care.
Default theme that comes with Sea Lion. So that brings us to the end of this section. In the next section, we're going to talk about the basics of C++. So I will see you in the next section.
Oh, you're gonna do 5M?
Now, let me give you a quick
Oh,
overview
okay.
of how I've structured this course so you can get the most out of it.
That's like the most popular like
This
roleplay
course
server,
is
right?
the first part of my complete C++ series. Each part is about 3 to 4 hours long, so you can easily complete it in a day or 2. In the first part, which is the one you're watching, we explore the basics. In this part, you will learn the fundamentals of programming in C++, data types, decision-making statements, loops, and functions.
Oh, let's go back. So,
Data types, decision-making statements, loops, and functions.
okay, let me write this down. So, my goal for this video is to understand these. Now, I actually already have a little bit of knowledge in C++. I've been kind of off and on studying it already for like the last month, but I'm doing a deep dive on it. So we're starting from the beginning. Basics. I'll title it Basics. We got fundamentals. So sorry, I'm taking notes. I'm a very heavy note taker. So I'm probably gonna pause a lot as I follow along. I'll probably write down all of the code that he like writes to. But I'm educating myself, man. Bro got set up Daz. Go. Data types. But yeah, I'm really happy with this new laptop, by the way. Lots of fun. There's this game I've been playing called Total Conflict Resistance, and I'm actually able to like just hit max graphics on it. It's kind of crazy. For the first time ever. It's really cool. But that means I'll be able to make games better also, I think, on this laptop. Because I'll have a lot more leeway with like the like the graphics and stuff. I won't have to like worry about optimization super hard, I think. Okay.
Functions. Now, throughout the course, I'm going to give you plenty of exercises to help you develop your problem.
Okay, so he does have exercises.
Build your confidence in writing code. In fact, many of these exercises.
I still have my wife. I gave it to my wife. So she's got a laptop and I got a laptop, so we can play games together.
Intermediate level concepts such as arrays, pointers, strings, structures, enumerations, and streams. And finally, in the last part, we'll be talking about the advanced concepts such as classes, exceptions, templates, containers, and more.
Okay, and notes. Notes. If he's gonna go over all of the points of each one, let me just write them down, I guess. So at least I have the understanding of what to expect. The understanding of what to expect. Okay, so hopefully I'll be streaming every day again. Now that I'm feeling better. And I'm back to learning, educating myself on how to make games. I want to make a game. I want to make a game by the end of the year. That is the goal. And every single thing I do, hopefully, is a step forward in the right direction, you know. We'll see, though. We'll see. Structures. Enumeration. Not the most entertaining streams, if I do say so myself, but educational, I guess, right? Maybe not. It's just me stumbling around. Okay.
And finally, in the last part, we'll be talking about the advanced concepts such as classes, exceptions,
Oh
templates,
yeah, go cat.
containers, and more.
Yeah, it's good list, but not remember away. Put some time that. Okay.
Such as classes, exceptions, templates, containers, and more.
Okay, containers and more. But he listed these. So live stream is fun. Well, I'm glad you say. I'm glad you think so, man. I'm glad you think so. Like I said, I haven't really been like streaming games. I only get so much free time, and now that I'm not sick anymore, all my free time's gonna go back to pursuing something greater. You know, pushing myself to actually learn something new. You know, and hey, if I make my own game, man, you know, who knows? I'll make my own studio, right? Make my own dev company, huh? Or game company, I guess. I could make my own games. That'd be kind of cool. Of course, we'll see if I can even learn this stuff.
So, by the end of
I'm
this
big
series,
dumb.
you'll have a solid understanding of C++, and you'll be ready to apply it in real life. For example, if you want to build games with Unreal Engine, which is a popular gaming engine,
I
you'll
do.
have the necessary C++ skills to build games.
Hey.
You just need to learn
Hey,
about
see?
Unreal
Hey,
Engine.
hey. All it takes is I guess these three videos, and I will be ready to make games. Okay, to keep you happy. Yeah, nice,
So
man.
I hope you'll stick around and master C++, one of the fastest
Well, I appreciate you stopping by and
most
hanging out with me
efficient
too,
programming
Gold Cat.
languages available.
Streaming is always more fun when you got people to hang out with, you know.
Hey guys, Mosh here. I just wanted to say that you don't really have to memorize anything in this course. I've put together a complete cheat sheet and summary notes for you that you can download as a PDF right below this video. So click the link in the description to download this PDF.
Whoa,
So
okay.
I have done my best to
I'm
create
taking
the
notes.
simplest C++ tutorial for you. So if you enjoy this, please support my hard work by liking and sharing this video. And also be sure to subscribe as I upload new videos all the time. Welcome back to the Ultimate C++ course. In this section, we're going to talk about the basics of C++.
Yes.
We'll cover variables and constants, naming conventions, coding mathematical expressions, writing to and reading from the console, working with the standard library, and comments.
Okay, hold on a second. Okay, he said basics on the other one. It said fundamentals of programming in C++. Data types, decision-making statements, loops, functions. This one says you'll learn variables and constants, naming convention. Oh wait, I think that's all of the fundamentals. Yum yums. Hard things want to quit eating chocolate, but love is at times. Oh. Okay, so I guess this specific course. Is going to teach me right now is variables and constants, naming conventions, mathematical expressions. Let me see if he breaks them up.
In this section, you'll be able to write simple but really useful programs in C++. Now, let's jump in and get started.
Okay, we got variables first and foremost. Okay.
All right, let's talk about variables. In programming, we use variables to temporarily store data in the computer's memory. Now, technically, a variable is the name of a location in memory where we can store some value. Now, because the value can change, we refer to this location as a variable. Now, to declare a variable in C++, first we have to specify the type of data we want to store. Let's say int or integer for storing whole numbers. Then we give our variable a proper, meaningful name, like file size. Now, there are various ways to name our variables. We have various conventions. We'll talk about them momentarily. Once we declare a variable,
take me back to school.
a
Oh, does it
distinct
really?
with a semicolon.
I'm
Now,
sorry,
I
man.
want to emphasize that you should always use meaningful names for your variables. Don't use abbreviations like FS, because someone else reading this code may not know what FS is short for. Also, don't go for names like F1 or F2 or thing. These are all cryptic and ambiguous, okay? So we're going to call this file size, and then we can give it a value like 100. So we assign it the value of 100. Now here we can combine these two statements into a single statement, and that makes our code shorter and more concise. So right here, where we declare our variable, we can give it an initial value of 100. This is called initializing a variable. Now we don't need the second line, okay? Now let's declare another variable for storing numbers with a decimal point. For that, we're going to use a different data type that is double. We're going to talk about different data types in the next section. So in this section, we're only going to work with.
Well, hold up. I need to go back for a second. This is what I fucking hate about coding, bro. So let me walk through this one more time. So
We refer to this location as a variable. Now, to declare a variable in C++, first we have to specify the type of data we want to store. Let's say int or integer for storing whole numbers. Then we give our variable a proper, meaningful name, like file size. Now, there are various ways to name our variables. We have various conventions. We'll talk about them momentarily. Once we declare a variable, then we terminate this statement with a semicolon.
Okay, so he made the name. He's got the name.
Emphasize that you should always use meaningful names for your variables. Don't use abbreviations like FS, because someone else reading this code may not know what FS is short for. Also, don't go for names like F1 or F2 or thing. These are all cryptic and ambiguous, okay? So we're going to call this file size, and then we can give it a value like 100. So we assign it the value of 100.
Okay.
Now here we can combine these two statements into a single statement, and that makes our code shorter and more concise. So right here, where we declare our variable, we can give it an initial value of 100. This is called initializing a variable.
I rewatched it. Okay, I rewatched it. And this guy, so he goes, takes an integer, right? I understand integers. I understand that, right? It's like whole numbers. Cool. He names it file size. Got it. He then takes file size, which is the name, and makes that equal 100. Now, what I don't understand. No, I think I understand everything. Actually, now that he's I understand. Okay.
Now we don't need the second line. Okay?
So I guess what he's saying is that people like to do that where they I think the concept is he's showing that you can do that. I'm coding. You were right, zombie. I'm feeling better now. Okay, I'm not like sick as a dog. AP3. Let's go. I just started. But you were right. I should learn C++. I'm learning C++. I have a compiler on my phone, right? So I can follow along with the videos. I have a compiler. See, and I'm taking notes. But this, I don't know why he did this. Why would he do this? Why not just do the first step and be like, this is a cleaner version? See, so my reasoning behind it is that I think I would have become dependent on. By the way, I got a new laptop. It's a new laptop, which is why the camera's garbage, because this one actually doesn't have enough USB ports for my mouse, my headset, my microphone, and then it's got like an HDMI port for my second monitor. I don't have another port for my camera. So that entire project is gone. I don't have my Unreal project anymore I was working on. No, I know I'm not going to use it. I'm not gonna, because I'm going to switch over to C++ instead of that. But no, it's fine. That's fine. No, I'd rather start over anyways. But I think the thing is I would have become dependent on that blueprint system, and then I would have been stuck with only Unreal Engine, right? I wouldn't be able to like expand my horizons or try different game engines. I think C++ is better because it's accepted, it's a bit more widely accepted, and I can use it using different things, not just Unreal. So I'm gonna learn. I'm learning C++ now. Okay. I got a new computer, and It's funny because this thing's actually a budget laptop. It's the MSI Katana 15. I mean, it was still like 1,500. I got it for 700 on eBay, but the dude didn't even have the right fucking like battery pack. I got scammed on the battery pack or the power block. I had to buy a power block. You can still use blueprints for things. It just shouldn't be microcode. Okay, but we're learning. We're learning C++. That's the thing, right? That's what I was trying to. I get distracted. Uh, Sorry. Seriously rearranging his face while his crew laughed. I'm so confused. Uh oh, you're at 91% download for GTA. Nice, man, nice. But yeah, this I don't understand. Why would he go through such a long process? I need to rewatch it one more time because maybe I just wasn't following along. I could have just spaced out.
Now, to declare a variable in C++, first we have to specify the type of data we want to store. Let's say int or integer.
Okay, whole numbers. Got it. Understand.
Then we give our variable a proper, meaningful name.
Okay.
File size.
I understand.
Various ways
Not
to
lost.
name variables and various conventions. We'll talk about them momentarily. Once we declare a variable, then we terminate this statement with a semicolon. Now, I want to emphasize that you should always use meaningful names for your variables. Don't use abbreviations like FS because someone else reading this code may not know what FS is short for. Also, don't go for names like F1 or F2 or thing. These are all cryptic and ambiguous, okay? So we're going to call this file size. And then we can give it a value like 100. So
yes.
assign it the value of 100.
Okay, so he's explained everything. I'm following along. But then he just does this. Watch what he does. Why didn't he do this in the first place? And then like just explain it.
These two statements into a single statement, and that makes our code shorter and more concise. So right here, where we declare our variable, we can give it an initial value of 100. This is called initializing a variable.
Okay.
Now we don't need the second line. Okay.
I hate coding. I quit. I already quit. I'm done. What was the point? What was the point? What are the odds someone learns C++ before they learn how to juggle a medium item? Oh my god, get the fuck out of here, dude. Okay, so he's just showing the stages. Okay, I guess I just wasn't following along the first time.
Variable for storing numbers with a decimal point. For that, we're going to use a different data type that is double. We're going to talk about different data types in the next section. So in this section, we're only going to work with integers.
So I'm just following along blindly.
Now
Got
we're
it.
Call this cells and initialize it to 9.99. Okay. Now that we have two variables, we can print them on the console. So instead of
hold on, I got
let's print file size. Run our program. We see 100. Beautiful. Now, while initializing variables is not mandatory, it's a good practice to follow. Let's see what happens if we don't initialize file size and print it on the terminal. Well, immediately we see this warning.
Well, I need to go back. This is a little. I'm trying to follow along, but my phone sucks and it's slow. My phone sucks and it's slow. You didn't space that. Then we go with the fancy brackets. Okay. Int. File size. God, I hate that you did the juggling thing. I'm so pissed right now. Who was that? Cerebral? Fuck you. You should always do it as one line though. Okay. I do have a second monitor. Okay, let me. I don't have a compiler. I guess can I just use Unreal Engine for this? Well, whatever. File size equal 100 semicolon, And then he goes double. What does double do? He didn't explain it. He was just like, I'll explain it later. You're just gonna blindly follow what I do right now. 9.99. And then we got STDs over here. Giving me C out. And we got the classic Hello World. Semicolon. Return 0. Okay, once again, I'm learning. I understand everything here except double. I don't know what double does. It's a float with double precision. I missed your first comment before the furiously. Bad. What did I miss? Okay, let's see. Gold cat, 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 gold cat. Cerebral furiously rearranging his face while his crew laughed. I don't get that reference. I don't get that reference. I don't get that one. It's a flow with double precision. Got it. Double floating point. Okay. Okay. So, I am caught up.
World, let's print file size. Run our program. We see 100. Beautiful. Now, while initializing variables is not mandatory, it's a good practice to follow. Let's see what happens if we don't initialize file size and print it on the terminal.
Well, it's gonna not work.
Immediately we see this warning. Let's take a look. The warning is saying variable file size is uninitialized when used here.
It worked. Okay.
Local variable file size. So our ID is complaining that we are using a variable that
I'm trying to focus. You left the door open. Okay, people are sleeping. I can't wake people up. Let's see. Return 0. Same amount of times you return the mid-sized item while juggling. You know what? I'm gonna make sure juggling isn't in my game. Okay, fuck you. Fuck juggling. By the way, I saw Matt Scott like rage posting on Twitter today. He supposedly we're gonna get APB by Friday. We'll see. Supposedly Friday. Okay.
Initial value. Let's run our program and see what happens.
But he's got no value for it, right?
Look, we get this random value, and if we run our program multiple times,
it's gonna give different numbers.
A completely different value.
Yes.
This is what we call garbage. This is the data that is currently in memory.
That file size is trash.
As a best practice, we should always initialize.
Is it not down? It's been down for like a month. I thought it was still down. I tried to download it today because I got the new laptop. And I wanted to test it on APB for whatever fucking reason. And it was telling me it was still down. So I think well, like I said, he was like rage posting on X or Twitter, and he said something about how they actually gave him a date, Friday. So well, okay.
Before using them.
I have no clue. I haven't played APB in years. Oh, really?
Yeah, in languages like C# or Java, we don't have to do this. If we declare an integer, it automatically gets initialized to 0. But this is not how it works in C++, okay? So this is how we can declare and initialize variables. And by the way, we can also initialize multiple variables on the same line. So over here, we can declare a second integer. Let's call that counter. So we add a comma and then declare counter, and optionally we can initialize it to some value. Now, while this works, it's often discouraged. As a best practice, we should declare each variable on a separate line. So I'm going to remove this and...
Oh my god, I'm on a phone, bro. Why would you do this?
Okay. Now I have a small exercise for you. I want you to write code
to
swap...
Fucking piece of shit, I hate this guy.
This is a common interview question, so let me explain what I mean. We're going to declare two variables, A and B. Now, if we print A,
I give up. I'm gonna get a compiler for computer. He listed a couple in the beginning. One was I think like MS Visual Studios or something. Let me just get that going. He said it was free. He's moving too fast. He's moving too fast for me. He said it's free. It better be free. Hmm. Okay. Where am I? Desktop development with C++. This one. And then I guess I'll do game dev too. Okay. Where's all the shit it's installing? Oh, hold up. Do I... Unreal Engine test adapter. Why not? Unreal Engine installer. Hey, who knows? I've already got Unreal Engine. Install. Okay. All that do is thing. Let's keep watching this.
Right? Now here's what I want you to do. Over here, I want you to write code to swap the...
I get off YouTube now. See you next time. Hey, later go, cat.
A, we see 2.
Stop using my phone.
B, we see 1. Now, I don't want you to reset this.
I got till tomorrow to make APP 3. There's no fucking way.
This is not the right solution.
Actually, you know, I could probably get away with it. You know how I could do it? You know how I could do it? Do links get filtered? Probably. Probably. But it doesn't even show it's blocked. Because it'll give me a notice, but is there a way I can get rid of link filter? Oh wait, no, there's no moderation at all on mine right now. Community moderation, let me see. I have like 0 moderation. You should be good. Oh wait, standard moderators, restream bot. Let's just get rid of that. Save. Okay, I shouldn't have a single moderator. It should be good. How's this MS Visual Studios thing going along? Looks like it's almost okay.
Let me give you a hint. Imagine instead of these 2 variables, we have 2 buckets. The first bucket is filled with...
It's not shut down. There was like a migration issue.
Now, if we have these
or the service provider that
think of a solution.
Let me pause it so I don't lose any info. Basically the service provider, whatever that Matt Scott's been using, they like did an unannounced server migration a month ago. Literally, it's been like a month now, and you know the game's just been down literally ever since. But like I said, Matt Scott was like ranting all day on Twitter. And he said that they gave him a date tomorrow, supposedly tomorrow, Friday. That's what he said, Friday.
And use that idea to write code to swap the value of these variables. It's not that difficult. Just spend a couple minutes on this and then come back see my solution.
Technically, it's still Wednesday for me because I didn't go to sleep, but it's technically Thursday. You know, it's midnight.
So to solve this problem in real life.
Okay, fuck. I'm actually literally not even.
To swap the value of 2 variables. This is a common interview question, so let me explain what I mean. We're going to declare 2 variables, A and B.
Mm-hmm.
Now, if we print A, we're going to see 1 on the terminal, right?
Yes.
Now, here's what I want you to do. Over here, I want you to write code to swap the value of these variables. So when we print A, we see 2, and when we print B, we see 1. Now, I don't want you to reset these variables, so I don't want you to set A to 2 and B to 1. This is not the right solution. Let me give you a hint. Imagine instead of these 2 variables, we have 2 buckets. The first bucket is filled with apples. The second bucket is filled with oranges. Now, if we have these 2 buckets in real life, how can we swap their content? Think of a solution and then use that idea to write code to swap the value of these variables. It's not that difficult. Just spend a couple minutes on this and then come back see my solution.
I don't understand. I'm lost. Let me listen to him one more time and see if I.
It's like, and then you two buckets apples. The second bucket is filled with oranges. Now, if we have these two buckets in real life, how can we swap their content? Think of a solution and then use that idea to write code to swap the value of these variables. It's not that difficult. Just spend a couple minutes on this and then come back see my solution.
We're just gonna look at his solution. I don't know.
So to solve this problem in real life, we need a third bucket. First, we empty
Use
our
the third
apples
bucket.
bucket into this bucket. Now the apples bucket is empty, so we can move the content of the oranges bucket here. Now the oranges bucket is empty, so we can move the content of the third bucket into this bucket. Now we have swapped the content of our buckets, right? So let's use
So
this
how would you
idea
put that in
to
code?
solve this exercise. We declare a third variable, we can call that temp, and we initialize it with what we have in A, that is the value of 1. Now we can set A to B, so whatever we have in B, which is 2, is now going to be in A. And finally, we're going to set B to temp, so B is going to be 1. So now, if we print A, we're going to see 2 instead of 1. Let's verify this. So let's run our program. There you go. Beautiful. So this was your first programming problem. If you got stuck, don't worry. It's completely normal. As we go through the core programming problem, we print A, set B to temp, so B is going to be 1. So now, if we print A,
Okay, so I see. I get it. Okay. It's so simple. It's so dumb. I hate that. So basically, I get it, right? So our temp bucket takes A, and then you just make A B, and B uses temp. So we're basically getting rid of.
we're going to see 2 instead of 1. Let's verify this. So let's run our program. There you go. Beautiful. So this was your first programming problem. If you got stuck, don't worry. It's completely normal. As we go through the course, I'm going to give you more and more exercises to help you build your confidence. Next, we're going to talk about constants.
Okay. I see. I didn't think about that. I didn't even think about that at all. I was like,
change. This is where we use constants. Here's an example. Let's declare a variable of type double and call it pi and set it to 3.14.
I think my Visual Studios is done. Hold on. Launch. I might have to make an account. Let me create an account. Oh god. No. Stop it. Oh shit, I already have an account. Fuck. What is this? What do you get out of here? I have this one, I have this one. What do I have so many of them? Sign in with Microsoft. You. And you. I don't need notes. Fuck. I don't know where my pen actually went. Start Visual Studio. Perfect. Look at that. We're going to do dark mode. Okay, I know the pen fills. It's my only pen. My only pen. Where'd it go? Okay. Well, I don't think I need notes. Okay, so we got it. We got it on the second monitor. I'll be able to follow along. We're going to do a open project or solution. Okay, never mind. I want to make a new project. How do I create a new project? Empty project. Next. Project 1. Perfect. Oh, dashboard. I wonder how much better you would be at this if that female army ranger took the fuck out of here, man. Okay. GitHub. I just want an empty. Just give me empty. Okay. Build successful. File new. File new project. Empty. Oh fuck. How do I Okay, help. So there's a debugger, don't need a debugger. I don't care for the copilot. Solution. Project 1. There's no place to type. Reference? Project 1. No, these are just files. What am I doing wrong? This item does not support previewing. Cool. Add to select repository. Why even? Header files? No. Can't type anywhere. There's no typing. There's no typing allowed. What the fuck is this? No. No, I don't know. I need to make a new file in the project. It's not that simple, is it? You know how dumb that'd be? There's no way. Add, run build, configure, start, setup. And then terminal? What's this? Oh, I don't think that's quite it. I don't think that's it. New item. Add. Oh my god, you're a genius. Okay. Oh, was it really just a file new? Well, I made it work anyways. Okay, we got one. We got source files here, Mr. File Name. Cool. So I can type up his stuff and actually follow along with him. Okay. Oh, it's so much faster. I'm already pretty much done. Where is it? Oh, it's right there. Ooh. There. That's gonna take a minute. I'm very. Then we enter double. I can't spell. And then he did pi equals 3.14. Oh, I don't remember the rest. Return 0. And then we got the fancy end bracket. Okay, cool. So I'm caught up. I have everything. Let me put this here, guys. Is chat still? Dinner time. I look forward to APP3. Oh, well, thanks for stopping by, Zombie. I appreciate it. That's literally not going to happen for like another 6 months at all, and that's just like the basic like mission system, just the base gameplay. Okay.
With this, we can calculate the area of a circle, right? But what if somewhere in our program, I accidentally set pi to a different value, like 0? With this, our calculations are going to go wrong, right? This is where we can use a constant to prevent the value of pi from changing. How do we do that? Very easy. We type the const keyword before declaring this variable. Now look, on line 5, we have a red underline. That is a compilation error. So if you hover our mouse here, we see the error
const
saying
double pi.
Cannot assign to variable pi with const qualified type const double. And also, if we try to run our program, here in the terminal window, we see an error. So take a look. This is the error. The error is happening in main.cpp on line 5 in column 8. And here's the actual error. Cannot assign to variable pi with const qualified type. Okay?
I see that. I see that.
So this will prevent us from accidentally modifying the value of this variable, or more accurately, constant. Now let's talk about naming conventions. So we have different conventions for naming our variables and constants, and different teams prefer different conventions. So there is really no right or wrong here. But let me show you the popular conventions. So earlier we declared a variable called file size. The way we name this variable follows what we call the snake case. So with this convention, we have to use lowercase letters to name our variables and constants. And if we have multiple words, we should separate them using an underscore. Now we have another convention called Pascal case, in which we should capitalize the first letter of every word. So the same variable using Pascal case looks like this. This is Pascal case. And by the way, the text that I put here that starts with 2 forward slashes, this is called a
Comments.
comment.
Yeah, I know comments.
For now, just remember that comments are a way to describe our code. They don't get compiled, okay? Now we have another convention that is similar to Pascal case. The only difference is that the first letter of the first word should be lowercase. So file size. This is camel case. We also have Hungarian notation.
God, that's so weird. Why would you do it that way?
And it's not relevant anymore. With Hungarian notation, we should prefix the name of our variables with a letter that specifies their type. So here we have an integer, so we use a lowercase I and then file size, just like
what?
This is called Hungarian notation. Now, quite frankly, this is a very old notation. It's not relevant anymore, but I still see people using it. I've seen it a lot in Windows source code. The reason this is not relevant anymore is because in the old days, we didn't have good editors. So if we declared a variable somewhere and we wanted to know its type, we had to scroll up to find the type of that variable. So
I see. So you're able to like classify things based off of the number or letter.
This is not the case anymore because these days we have powerful editors. If we simply hover our mouse over any variable, we can see its type. So here you can see file size is an integer variable, right?
Oh, that's cool.
So these are the
okay, I see.
I'm going to use camel case for naming our variables and constants, and Pascal case for naming our classes. We'll talk about classes later in the course. Now, if you don't like these conventions, I prefer to use...
No, hold on. I think that's actually noteworthy. Fuck. I actually need to find my pen. Who's that? That's my pen. Okay, I gotta find my pen. Fuck. I got one. I found a pen. I found a pen, not the pen I was using, but it's a pen. It's not gonna end up in the laundry, yum yums. Okay. So I think this is really weird. I don't necessarily like the Hungarian notation, but notes. So I'll say cases. Cases. Okay. So when everything is lowercase, that when everything is capitalized, we have Pascal. When you have a lowercase, let me make sure. Okay, lowercase. And then a caps. Camel case. Camel case is weird as shit. I don't know why you would ever want to do that one. I'm sure there's actual proper reasonings behind all this, but I hate it. It just looks terrible. Caps. Caps. File. Size. This is Hungarian. I actually really like. The more I look at it, the more I actually like the Hungarian one. I don't know why. Because you're putting like the classification of it, like the variable classification in it. So you kind of know what it does. I think that's kind of cool. I think that's kind of cool. But back to full screen.
use snake case, that's totally fine, but make sure to stick to your own convention. The more consistent your code is, the easier it is to read, understand, and maintain it. Next, we're going to talk about mathematical expressions. So you have learned how to declare variables and constants. Now let's see how we can write mathematical expressions for performing calculations. This is where the fun begins. So I'm going to declare two variables, x and y. Now we can declare a third variable and set it to x plus y. So what we have
Will it
here is
actually do the
called
math for
an
you?
addition operator, and x and y here are called operands. So now let's print z on the terminal. So std double colon cout z.
STD.
So now we see 13. Beautiful. We also have subtraction, multiplication, and
Int
division.
y
But division is a little bit tricky.
equals
In this
3.
case, because we're dealing with two integers, the result of the division is going to be an
Z
integer, even though in
equals
reality,
x.
dividing 10 by 3 is going to result in a number with a decimal point, which we call a floating point number in programming.
STD.
So if we run our program, we see 3.
See
But
out.
what if you want to see a floating point number? Well, changing the type of z to double is not going to solve this problem because, as I told you earlier, if both our numbers are integers, the result of the division is also going to be an integer. So to get a floating point number, we have to convert one of these numbers to a double. So take a look. First, the warning goes away. Now, if we run our program one more time, look, we get 3.33.
Okay, so in order to be able to do division, I have to turn the first one to a double. And then z is effectively a double as well. In order for that to function, correct? It disappeared. 3.333333. Okay, yeah, perfect.
Okay, so this is how division works in C++. Now let me.
Okay, so specifically for division, that's how that works. Everything else I can just have as a standard integer, right?
Out z. Take a look. So now we.
Okay. That's kind of cool. You can just do math. Let me see. Let me see what I can. Here. I gotta get rid of that camera. I guess. Kind of pointless at the moment. So when doing math. When doing math, addition, subtraction. What about multiplication? Does he go over multiplication too? I'll leave it. Can be standard integers, and dividing I'll just set up the standard setup here. X 10, Y 3. Okay. Okay. Got it. Got it.
We see 13. Beautiful. We also have subtraction,
Subtraction.
multiplication, and division. But division is a little bit tricky. In this case, because we're dealing with two integers, the result of the division is going to be an integer, even though in reality, dividing 10 by 3 is going to result in a number with a decimal point, which we call a floating point number in programming. So if you run our program, we see 3, but what if you want to see a floating point number? Well, changing the type of z to double is not going to solve this problem because, as I told you earlier, if both our numbers are integers, the result of the division is also going to be an integer. So to get a floating point number, we have to convert one of these numbers to a double. So take a look. First, the warning goes away. Now, if we run our program one more time, look, we get 3.3333. Okay? So this is how division works in C++.
Oh, okay,
Now,
I see, I see.
Revert this back to.
Let me. For. Okay. Fuck. That page is full. Look at this. I got a whole full page already of notes. I've taken so many notes. I'm such a good boy. I'm gonna learn this so good. Just you wait. I'm A plus.
Integer and integer.
A plus. A plus
another
plus.
operator
Plus
called modulus, which returns the remainder of a division. So what is the remainder of division of 10 by 3? It's 1. Let's verify it.
Oh, it's a percentage, right? User's looking
There
for
you
a.
go. Okay. Now, using these operators, we can modify our variables. I'll show you what I mean. So for simplicity, I'm going to remove y and z. We only have x, and we're going to print it on the terminal. Let's say we want to increment x by 5. Here's how we do it. We type x equals x
Plus 5. Yes.
So first, this piece of code or this expression is going to get evaluated. The result is 15, and then the result will be stored in x. Okay? Now, similarly, we can subtract 5 from x. We can multiply x by 5, and so on. Okay? Now, we also have two more operators you need to know, and they are increment and decrement operators. So let's say we want to add 1 to x. We can say x equals x plus 1. That is totally fine, but there is a shorter and more concise way to write this code. We can say x plus plus. This is the increment operator. We also have decrement operator, but we don't have the equivalent for multiplication or division. Only increment and decrement, okay? Now, this increment operator, there are two ways we can apply it. We can apply it as a postfix or as a prefix. Let me show you the difference. So I'm going to delete these two lines. Let's declare another variable called y and set it to x plus plus. If we apply this as a postfix, first, the current value of x, which is 10, is going to be assigned to y. So y is going to be 10, and then x will be incremented by 1.
Okay.
So if you run our program, x is going to be 11, but y is going to be 10. Let me show you. So
notes. I think that it's something I might actually want to remember. Increment and de-increment. Decrement. X. Okay. And then you can also have it the other way. I want to see what that's supposed to do, what she's going over right now.
We print x is 11, but if we print y is going to be 10.
Y is 10.
So let me add this as a comment for clarity. In this case, x is going to be 11 and y is going to be 10. Now, what if we apply the increment operator as a prefix? So we declare another variable and set it to plus plus x. In this case, because we applied this operator as a prefix, first, the value of x is going to be incremented by 1. So x is going to be 11, and then the result will be stored in z.
Mm-hmm.
So in this case, both x and z are going to be 11. Let's verify it. So if we print z,
How interesting. Okay. Okay. I'm gonna kind of. I'm pausing, guys. I'm pausing. Learning notes. Lots of notes. This is to teach me about increments. Increments and how program recognizes increments. X plus plus. Plus 2 is x equals 11. And x 11. The okay.
are going to be 11. Let's verify it. So if we print z, well, in this case, z is 12. I made a mistake because in the previous statement, we incremented x by 1. So if we comment out this line, it's not going to get executed.
Oh my god.
But we run our program, it's going to be 11, and z is going to be 11 as well. Let's verify it. So here's z, beautiful. And let's also print x. There you go.
I hate you. I hate you.
So here's what you need to take away. If we apply the increment or decrement operator as a prefix, first, this piece of code is going to get evaluated. So first, x is going to be incremented by 1, and then the result is going to be stored in the other variable. In contrast, if we apply this operator as a postfix, first, the current value of x, which is 10, is going to be stored in y, and then x is going to be incremented by 1. Hey guys, Mosh here. I hope you have been enjoying this tutorial so far. I just wanted to let you know that this tutorial is the first hour of my complete C++ series where you will learn everything you need to know from the basics to more advanced concepts. So watch this tutorial to the end, and if you still want to learn more, use the link below this video to enroll in the full course. The complete course contains 3 parts, each part being around 3 to 4 hours long, so you can complete them in a day or 2. You will also get a certificate of completion and a 30-day money-back guarantee. Again, if you're interested, the link is below this video in the description box. When writing mathematical expressions, especially the more complex ones, you need to take into account the order or priority of operators. Let me show you what I mean. So I'm going to declare a variable called x and set it to 1 plus 2 times 3. Now, let's print x on the console. What do you think we're going to get? Pause the video and think about it for a second.
Like 9?
The answer is 7. This is a very simple math question, but unfortunately, a lot of people get it wrong. Here's the reason. In math, the multiplication and division operators have a higher order or a higher priority. So when evaluating this piece of code or
Oh my god, are you fucking kidding me? I did it wrong. No. I thought you went left to right unless it was within parentheses. I thought you went left to right unless it was in parentheses. Bro, dude, there's no way I fucked that up. Or is that some kind of crazy fucking...
First, this part is evaluated. So 2 times 3 is 6. And then
7
is added to 1, so the result is 7. Let's verify it. So I'm going to run the program. There you go. We have 7. Okay. So here's what I want you to remember. In math or any programming languages, the multiplication and division operators always have.
Okay. That's dumb. That's dumb. You just made me feel like a full-blown idiot is what you did. You fucking fuck you. Multiplication and multiplication and division take first priority over addition. Okay.
A higher priority than addition or subtraction operators. But we can always change the order of these operators using parentheses.
Yes, of course.
So in this case, if we wrap this piece of code with parentheses, first this piece is evaluated. So 1 plus 2 is 3, and then 3 is multiplied by 3.
Which
so
gives you 9.
The result is going to be 9. Let's verify it. So run the program one more time. There you go. Okay? Now here's your exercise for this lesson. Take this mathematical expression and implement it in C++. Assume x is 10 and y is 5. So if you implement this correctly, z is going to be 1.3.
Well, okay, you can try it. Let me write it down first, and then I'll move the camera over. Z equals 10 divided by multiplied by 1. Okay. That's kind of simple, huh? Kind of simple, huh? Kind of simple, huh? Kind of simple, huh? So it's not even that hard, boyo. That's not that hard. I could do that in my sleep. So we're gonna do z equals parentheses x Does he have an x and y? No. Plus 10. And then we go divide parentheses 3 times y. Okay. I'll do double. Actually, no, that should just solve itself, right? Let's see. Never mind. So dumb. Let's see. X is an undeclared identifier. Okay. What did I fuck up?
So pause the video and work on this for a couple minutes, then come back see my solution.
I mean, I laid it out, but
Alright, here's the solution. I'm going to declare x and set it to 10. Then y, we set it to 5.
where did he get these numbers from?
And for z, first we have to add 10 to x, but we have to wrap this in parentheses because...
Okay, hold on. So, I didn't do it wrong. He just fucking came up with, like, some goofy stuff. So everything is in double from the looks of it. So x equals 10. Where did he get the fucking 10? What did you do, boyo? What'd you do? How'd you get the 10? Oh, well, where did 10 come from? You cray cray. Was I supposed to figure that out? Did he give me an answer?
This whole thing is going to be our numerator. Once we have the numerator, then we're going to divide it by 3 times y. But here's the
Yes.
tricky part. We have to wrap this whole expression in parentheses because the result of this expression is going to be our denominator. If we don't use parentheses here, our denominator is going to be 3, and the result is going to be different. So we wrap this whole thing
Not yet.
in parentheses, and now let's print z on the terminal.
Oh,
So we should get
you did C out. What did I do? Hold on, hon. 1 second. I'm learning. Gotta get those STD first. C. The problem is this isn't. I mean, that's not wrong.
1.3. Again, if you didn't solve this properly, don't worry, don't let that discourage you. Remember, you're a student, you're learning. If you know everything and you could solve every problem, you would be the one teaching, right? So don't let that discourage you, and let's move on to the next lesson.
But I don't understand, mate. It should be like that. I've got errors. No? What is it, Yummy? Oh, I forgot about that. Yes, hon.
So you have learned how to write to the console or the terminal window. In this lesson, I'm going to show you a few more techniques for writing to the console. So let's start by declaring a variable. Now let's say on the terminal, we want to print x equals 10. How do we do this? Well, first we go in the std namespace and pick up cout, which is an object that represents the standard output stream. I know, it's a mouthful, but let me explain it for you. In programming, a stream represents a sequence of characters. The standard output is our console or terminal window. So using cout, we can write a sequence of characters on the standard.
What? Was there? The door closed? The door closed? I hate C++, by the way. It's not fun.
Standard output, which is our console window, right? Now,
What's up, hon?
these double left angle brackets are called the stream insertion operator. It's an operator for inserting something to our output stream. In this case, we're going to write a sequence of characters which we specify using double quotes. Now in programming or C++ specifically, this is called a string. We'll talk about strings later in the course. So here we want to print x equals, and right after we want to print the
Huh? Yeah, I'm still streaming. That's good. It works. Yeah, it works. What? Okay.
actual value of x. So we terminate this statement and use cout one more time. But this time we print x, okay? Let's run our program and see what we get. So we see x is 10. Beautiful. Now, we can combine these statements into a single statement. So we get rid of the second cout and this semicolon, and then put everything on the same line. Now we are chaining multiple stream insertion operators. So if we run our program one more time, we get the exact same result. Beautiful. Now, what if we declare a second variable? So let's declare y and set it to 20, and then repeat. So one more time, cout, y equals, and then we add y. Take a look. All right, here's what we get. But wouldn't that be nicer if y equals 20 was on the second line? Well, to solve this problem, right here, we need to add a new line. So once again, we chain the stream insertion operator. And this time we go in the std namespace and pick up endl, which represents
End
the
line.
end of the line. Okay? Now, let's run our program one more time. That is much better. Okay? Now, once again, we can simplify this code by combining these two statements. So again, we don't need the second cout. So let's remove that and this semicolon as well. Now, if we run our program, we get the exact same result. However, our code is not formatted properly. It's a little bit hard to read this code. So here I'm going to use tabs and spaces to align these operators. So what we have in our code looks exactly like what we expect in the output. Okay? This is better.
Huh.
Now, there is a tiny problem in this code. We have a bit of repetition of std double colons. So we have repeated this in two places. Let me show you how to simplify this code. So before our main function, we use the using directive to pick up the std namespace. So here we type namespace std. Now std is defined anywhere in this file, so we don't have to repeat it in multiple places. So we can simply access all objects in the std namespace. So let's remove that, and this one as well. And finally, let's realign these brackets. Great. So now our code is cleaner, more concise, and easier to read. Great. Now here's your exercise. Imagine you have a store and you have made $95,000. Now as part of your tax return, you have to pay state and county tax at different rates. So state tax is 4%, whereas county tax is 2%. Now I want you to write code to show your total sales, as well as your state tax, your county tax, and the total tax you have to pay on this income. So pause the video.
Okay. I got it. I got it. I understand. Thank God his stuff is like, thank God his projects are like grade school level. He's like, I walked you through this course. Now do this exact project based is purely off of the course I just taught you. Oh, okay. Thank goodness. Right? So we got sales. So we're gonna scribble, 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 scribble. Okay. Sales. We made this year. We made $95,000, almost 100 grand. Oh my! But we got state tax here, 4%, and of course we got that county tax, taking 2%. Okay, and then he wants what I have left after it all, right? So let's see if I can do that. Now, the thing that I need to look at one more time was he did that namespace thing. Okay. I think I can do this. I think I can do this. I can't. I can't do. I can't do this. It's so hard. Okay. We'll get rid of like all of this basically. Okay. No, we still need int main. But using namespace std. So I don't understand that, right? So let's set up using namespace std, right? Using namespace std. Exactly how he had it set up. And we'll do int main. The parentheses, I don't understand the parentheses either. Why are the parentheses there? Okay. And then we got our first integer. Our first integer is 95,000. Int. I think it's like x equals 95,000. It is math. So y, which is going to be state tax, is going to be or divided by 95,000. I don't think that's actually how that works, but I just want to do a C out real quick. And the line, oh, this needs to end up 2. Okay. By 4 divided by 95,000. If I did C out Y should fuck. What did I do wrong? So we have divided by x. 4 divided by x. CL of y. Oh. Zero. Do they both have to be doubles? For that to work? 4.21053. Okay. Close enough. What happens if I run it again? Okay, so it's the same thing. Okay. So y is my sales tax. Is my state tax. Z, so let's add another double here. Double. Z equals 2 divided by x. Okay. Now, here, okay. So I got one more. I got one more to do. We're gonna do a double. It's going to be A equals 95,000 subtracted by y subtracted by z. If I did A, run it. I did it wrong. No, that's not what it's supposed to be. Fuck. Okay, well, we'll ignore that for now. Let's see. So we got a string.
Holy shit, no.
Cells equals, and then we'll go x. Oh no 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 no. Yeah. Okay. We close the string. We do the next string, and then it's going to be x. And then we will end the line. How did he end the line? And L. Okay. Then we're gonna do another string. This is gonna be state x equals and it's gonna be y and we end the line. Country tax, county tax equals, oh, that's a plus. And equals B. We end the line. I'll do remaining profit.
No.
God, bro. Okay. Hey. Thing is, I want to also see this. Not until all of it's done. We do it right here. Just. I'm very close. I'm very close. Of course, I got random ass numbers in there. So I don't think I did it right. That's like what, only $4? Okay, I must have done it wrong. I must have done it wrong. So let's, for now, we'll do x divided by 4. That's not right either. Well, at least it affected this. So let's say 0.4. Okay, no, that's that fucking. I mean, I owe more than what I made. 0.4 divided by x. We're back to the non-numbers game. Okay. What have I done wrong? Why is it not working? Crap. Help. I need an adult. What if we x multiplied multiply 0.4? There's no way that's 4%. I think I have to do something extra, right? Like maybe divide by 100 or some shit like that. I think I have to. Okay, hold on. Google. What is 4% of 9,500? 380. Okay. Hey, I did it. Okay, so I did do the math right. Okay, okay, okay. See, that looks a lot more appropriate. So now that I know how to do this, we will do x multiply 0.2 divide by 100. Okay, so if we whoop 190, 380, 190, and it'll be 94,430 for total profit. That looks about right to me, huh? That looks about right to me. Let's see. Let's see what he did. But that is what I managed to accomplish. Very happy with it. Very happy with it. Let's see what he got.
This one as well. And finally, let's realign these brackets. Great. So now our code is cleaner, more concise, and easier to read. Great. Now here's your exercise. Imagine you have a store and you have made $95,000. Now, as part of your tax return, you have to pay state and county tax at different rates. So state tax is 4%, whereas county tax is 2%. Now I want you to write code to show your total sales, as well as your state tax, your county tax, and the total tax you have to pay on this income. So pause the video and work on this exercise for 5 minutes.
I did it,
Then
boy.
come back, see my solution.
See. Let's see.
All right, here's my solution. First, we need a variable for storing the total sales. And for that, I'm going to use a double. So even though we don't have any cent values here, but for monetary values, we should always use a double. So double sales equals 95,000. Now, right after, let's print the total sales. Here we add a dollar sign. That's nicer. Then we chain the insertion operator to print sales, followed by the end of line. Now, before going any further, let's run our program and make sure everything works. So, run. Total sales is $95,000. Great.
Okay, his is a little nicer looking
Next, we
than
need to
mine.
calculate the state tax. So let's declare another variable called state tax. And here we get sales and multiply it by 0.04. And then once again, we print this on the terminal. So state tax is this value followed by the end of line. Now, once again, let's run our program and make sure everything works. So this is how I want you to write code. Write a bit of code, run it, make sure everything works before going further. Baby steps. So run. So our state tax is 3,800. Great. Now let's improve this code. The first thing I want to improve here is formatting. So the first 2 lines are about the total sales, whereas the second 2 lines about the state tags. These are two different stories, right? So here I add a vertical line to separate these stories. Just like how we have multiple paragraphs in an article, we want to write our code so every story is separated from other stories, okay? So here's our state tags. Then I add another vertical line to separate it from the return statement. Great. Now, this line is totally fine, but generally speaking, it's best to avoid magic numbers like this here, because even though this is a very simple example, in more complex programs, these magic numbers might be confusing. Someone else reading your code may not know what that number represents. So here we can make our code more expressive by storing this value in a separate variable. So we declare a variable called state tax rate and set it to 0.04. And then we can reference that variable right here. Now it's completely clear what this value represents. It's our state tax rate. But this has another benefit. If we use this variable in multiple places in our code, and then tomorrow the state tax changes, we don't have to come back and modify multiple places. We have a single place where we have stored this value, okay? Now, there is a tiny problem in this code. The problem is that I can accidentally change the state tax rate. How can we solve this problem? Using a constant.
Yeah.
We qualify this with the const keyword. That's better. Now we have to repeat the same 3 lines for our county tax. So I'm going to copy this and paste it. And again, note the vertical line. This is to separate these stories. So over here, we're going to rename this to county tax rate, which is going to be 2%. And over here, we're going to calculate the county tax and print it accordingly. County tax. Good. Nothing new. Now we should also replace state tax rate with county tax rate. So let me show you a shortcut here. Look, I haven't typed county tax rate. I just typed kind of an abbreviation. So count TR. So we can use abbreviations to quickly type our code and press enter to complete it. Okay. Now let's run our program and make sure everything works. So our county tax is 1900. Beautiful. Now the final part. We declare another variable called total tax, which equals state tax plus county tax. And finally, we print it on the terminal. Total tax.
Oh, he wanted the total tax.
So once again,
I went with
see
the
how I've
profit.
named my variables. All the variables are properly named. They're meaningful. There is no ambiguity in this code. We don't have T1, T2, TR, whatever. Don't write code like that. Next, we're going to talk about reading input from the user.
Boy, did I fuck up. I didn't even have the right final one. I went with like the profit after the taxes. But even then my math was wrong. Because I did 0.4 instead of 0.04. And then 0.2 instead of 0.02. So yeah, bam. But of course I went with total profits. He went with total tax. Oops.
All right, now let's see how we can read input from the console. So you have learned that cout represents the standard output string. Now in this file, in iostream, we have another object called cin, which represents the standard input stream, which we can use for reading data from the console. Let me show you how. First, we're going to use cout to print a label on the screen. So enter a value. Now using cin, we can read that value and put it in a variable. But first we need to declare a variable. So let's declare an integer called value. Then we use cin along with the stream extraction operator to read that value and put it in this variable. Okay? So this is called the stream extraction operator. It's the opposite of stream insertion operator. I know it can be confusing, but the easiest way to remember this is to think of the direction of data flow. So in this case, we are reading data from the console or the standard input and putting it into this variable. In contrast with cout, we're basically getting this sequence of characters and putting them into the console. So this is the way to remember this, okay? Now, to verify that our program works, let's print the value that we just read. So let's run our program, enter a value, let's say 10, and we get 10 in the output. Beautiful.
Yo, that's fucking crazy. What?
A float say 10, our program works. So this is getting this read to remove. So this is called the stream extraction operator. It's the opposite of stream insertion operator. I know it can be confusing, but the easiest way to remember this is to think of the direction of data flow. So in this case, we are reading data from the console or the standard input and putting it into this variable. In contrast with cout, we're basically getting this sequence of characters and putting them into the console. So this is the way to remember this, okay? Now, to verify that our program works, let's print the value that we just read. So let's run our program, enter a value, let's say 10, and we get 10 in the output. Beautiful.
That's
Now,
so
what if we
fucking.
enter
That's so ridiculous. Hold on. Hold on. Hold on. I'll be fucking with shit like that. Oh my god. Listen, I'm not trying to fucking do that nonsense. Okay. Oh, that's not the whole.
say 10, that our program works,
Okay. So we got the cout, right? Print string. A value. Okay. And we and that. Now we want to make the integer named value cin takes that data value cout value. You okay, Yamios? Do 100. That's wicked, man. 23. Enter. That's so cool.
let's print the value that we just read. So let's run our program, enter a value, let's say 10, and we get 10 in the output. Beautiful. Now, what if we enter a floating point number, a number with a decimal point? Let's see. So this time I'm going to enter 10.1.
But you only get 10.
Part is gone.
Okay.
Because we declared this value as an
As
integer.
an integer,
So
not a
if you
double.
want to read a floating point number, here we have to use the double type. Take a look. So one more time, 10.5. Now we get 10.5. Beautiful. Now, we can also read multiple values. So let's change this label to enter values for x and y. Now, let's declare two variables called x and y.
Well, I'm gonna follow him.
First we read x, and then we read y, and finally we can print x plus y. This is like a simple calculator. So take a look. We can enter 10 and 20, and the result is 30. Now we can also separate these numbers using a space, and the program will still work. Take a look. Now we can. This is like a simple.
And 20, 30.
Calculator. So take a look. We can enter 10 and 20, and the result is 30. Now we can also separate these numbers using a space, and the program will still work. Take a look. So one more time, 10 space, it doesn't matter one or more spaces. We add the second number and we get the same result, okay? Now, similar to cout, we can chain these statements together. So we can get rid of the second statement and chain the stream extraction operator to read the second value. So look, we start from the console, we read something and put it in X, then we read something else and put it in Y. It's exactly like before, but our code is shorter. So this is how we can read input from the console. Now, as your exercise, I want you to write a program for converting temperatures from Fahrenheit to Celsius. So when you run your program, the program should ask the user to enter a temperature in Fahrenheit, and then it should convert it to Celsius and print it on the terminal. So pause the video and spend a few minutes on this, then come back see my solution.
You know, it's kind of scuffed. I don't know the conversion rate between Celsius and Fahrenheit. Conversion. Oh my God. Celsius equals Fahrenheit subtracted by 32 times 5 divided by 9. What? Okay. Well, we need that. So basically, it's enter value for Fahrenheit. We don't need to. Fahrenheit. We only need Fahrenheit. And then cout will take the subtract by 32 times 5 divided by 9. Let's see if it worked. Let's see if it works. Okay, so let's say it's like 32 degrees, right? 32 degrees. 0. That sounds about right. I'm pretty sure 32 degrees is 0. So let's try this again. Because I probably chose like the one number that you probably should be doing. So we'll say it's what, like 90? Let's give it a nice warm like 76-degree day, huh? It's 24.444444 Celsius. Is that right? Why is it so scuffed? Why is this such a scuffed system? I got no idea. Okay, but this is my solution to the problem. This is my solution to the problem. Let's see what he does. Let's see what he does.
All right, here's the solution. It's pretty easy. First, we use cout to print a label like Fahrenheit. Then we declare a variable for storing the temperature in Fahrenheit.
Oh, he's going.
Fahrenheit. Next, using
I did a
cin,
double.
take that value and put it in this variable. Then we declare a variable of type double
Are you dying?
called Celsius. The reason I'm using a double here is because the conversion might result in a floating point number. So here's the formula. Fahrenheit minus 32. We wrap this in parentheses and then divide it by 1.8. Now finally, using cout, we print the temperature in Celsius. Now let's test our program. So 90 in Fahrenheit is equivalent to 32.2 in Celsius.
Okay, well, let me see if I did my math right. So 90. We'll give it a nice warm, nice hot ass fucking 90 degrees. 32.2222222. Okay, well, I did the math right. But my code looks a little bit more different than his.
So you have seen that the standard library gives us the capability to read from or write to the console. Now in this lesson, we're going to look at a different part of the standard library that gives us several useful mathematical functions. So on the top, we're going to use the include directive one more time to include a file called cmath. This file declares a bunch of useful mathematical functions. Now if you're curious what these functions are, just go to Google and search for cmath reference. There are many different websites that give you a C++ reference. One of them is c++.com. The other is cppreference.com and so on. So as an example, let's look at this page. So over here, you can see all the functions declared in the cmath library. In this lesson, we're going to look at a couple of them. One of them is ceil, which rounds up a value. The other is floor, which rounds down a value. Now, if you click on any of these functions, you can learn more about it. So on the top, you can see different versions of C and C++. So C90 and C99 represent the old C language. C++98 is one of the early versions of C++ that came in year 1998. Then we have C++11 that was released in year 2011. So you can see how this function has evolved over different versions of C or C++. Now, don't get hung up too much about these details. All I want you to pay attention to here is that this function takes an input of type double and returns another double. So let's see this in action. So back to the code. Here in the main function, to use the floor function, we type floor.
Oh, he's got using namespace. Hold on. Let me add that in too. Because that makes life insanely easy. Okay.
Followed by a pair of parentheses, and then we supply the input value, which is called an argument. So we pass 1.2. Now we get a double value that we can store in a variable. So let's declare a variable of type double called result and set it to the return value of the floor function. And then we terminate this statement with a semicolon. Now over here, we say that we are calling the floor function, which means we're executing it. We're giving it a value and getting a new value. Now we can print the result just like before, and the result is 1. Okay? Now, some functions take multiple values or multiple arguments. One of them is the pow or power function. So,
1 second. 1. What was his?
or it's 1. Okay?
Okay.
Now, some functions take multiple values or multiple arguments. One of them is the pow or power function. So, let's take a look. Pow requires 2 arguments. Here we need to pass 2 values separated by a comma. So if we say 2, 3, that means 2 to the power of 3. Now, when we type this, CLion adds these labels, LCPP_X and LCPP_Y. These are the name of the parameters of this function. So CLion adds this to make our code a bit more understandable. Okay? Now, if we run this, we get 8. Okay?
Okay. Yeah, I got it.
Now, as an exercise, I want you to write a program that asks the user to enter the radius of a circle, and then it should print the area of a circle. It's pretty easy. You can knock it out in a couple of minutes.
Bruh. Okay, hold on. Don't give me the solution yet. I'm gonna stop here. It's 2 in the morning. I'll get back to this in the morning.
You've likely seen videos on YouTube telling you the #1 programming language to learn right now if you want to be rich. That's not what we're doing today. Instead, we're going to travel to the deepest, darkest depths of the software engineering field to discover the programming languages that are loved, hated, beautiful, ugly, compiled, interpreted, useful, weird, and everything in between. If you make it to the end, you'll have a roadmap for everything you need to know to land a job as a junior developer in 2023. Or it might just make you extremely depressed, because this iceberg is just the tip of the iceberg of what you actually need to learn. Choose any language and you'll find another iceberg within this iceberg that goes on forever, like a Mandelbrot set, which ironically you can represent in code with any one of the languages we're about to look at. Before we get started, there's quite a few programming icebergs out there, but this one ranks languages based on where I think you might encounter them as a beginner learning how to code from scratch. Each level has its own theme, so let's get right into it with languages that are designed to make programming as easy as possible. If you know absolutely nothing about programming, the best place to start, in my opinion, is Scratch. It was developed at MIT like some other languages on this list, but instead of typing out code, you drag and drop these blocks together like Lego bricks to represent things like variables, control flow, and operators. It makes the thinking process behind programming much more accessible, and you might be surprised at what you can actually build with it. Long before Scratch, though, we had BASIC, or Beginner's All-Purpose Symbolic Instruction Code, which came out of Dartmouth in 1964. At the time, Fortran was all the rage, but it wasn't beginner-friendly. BASIC provides a bunch of basic commands like print, goto, and for, and was included in most personal computers, which made it the go-to option for people learning to code for the next 50 years. Now, moving on to the next tier, we have the extremely popular, dynamic, high-level languages. The language most people start with today is Python, primarily because of its minimal syntax. It doesn't require curly braces, semicolons, and stuff like that, and instead uses indentation to represent different blocks of code. The other popular high-level language is JavaScript. Syntactically, it's pretty ugly, but it's a requirement if you want to do web development, and almost every developer will have to touch it at some point in their career. Any application that can be written in JavaScript will eventually be written in JavaScript. Now, after learning one of these languages, you'll be able to build pretty much anything you can imagine, and you could have an entire career as a software engineer without going any further down the iceberg. But you don't want to be on your deathbed wondering if you should have tried out PHP. On this next tier, we have languages that are extremely popular, but a little more specialized. Programmers like to get things done from the terminal, and there are scripting languages like Bash and PowerShell that allow you to interact with your computer programmatically. Instead of typing out the same commands over and over again, write a Bash script to make it reproducible. Now, if you get into web development, you'll also need to learn HTML and CSS, which when combined together, arguably form a Turing-complete programming language. They're not used for programming in the traditional sense, but rather to define the structure and style of of a website. And if I were to say HTML is not a programming language, I would be immediately canceled by the tech community. In addition, most apps need a database, and the most common language for working with databases is structured query language. You can call it SQL, SQL, or Squeal. It is Turing complete, although not used for regular programming, but rather to read and write data in a relational database. Now, Python is great and all, but there are many other dynamic languages that might be a better fit for certain projects. Like PHP made it easy to build server-side web apps in the 90s and is still very popular today. Lua is easier and faster than Python and is embedded into many engines like Roblox and World of Warcraft. Ruby is an easy-to-learn
World of Warcraft is
language
based off
also
of
commonly used to build web apps
Lua?
with the Rails framework. If you work in data science, you'll come across R, which is used for statistics and data viz, or Julia, a more modern option, also used for scientific computing. The one thing all these languages have in common is a dynamic type system. However, as you build more complex software, you may realize that you need a more rigid framework, and one way to accomplish that is with a static type system. This tier makes up the bulk of production code out in the world. First up, we have Java, which kind of revolutionized programming with the Java virtual machine. It compiles to bytecode that runs on the JVM, and that allows developers to target any computer architecture from a single codebase. Syntactically, it's an absolute dumpster fire for beginners. I made an entire video about why people hate Java, but having explicit types in your code can make it much easier to understand and refactor, and modern IDEs like IntelliJ will pretty much make the code write itself. Java is legendary, but it was followed up by Microsoft with C#. It's similar to Java in many ways, but gets a lot more love from its users. It's used to build games with Unity, as well as web and desktop apps with the .NET framework. Another well-loved tool from Microsoft is TypeScript. It takes JavaScript and adds a type system on top of it, making it much easier to work with on large complex projects. If you're building a mobile app today, you'll likely be working with Kotlin for Android, Swift for iOS, or Dart with the Flutter framework. These languages are all statically typed, but they go about it in a more modern, concise way with features like type inference that minimize boilerplate code. Next up, we have Go, which is a high-performance language developed at Google to build low-level systems. It was designed as a replacement for C, and Ken Thompson, one of the original creators of C, helped design it. The syntax is nice and concise, making it approachable to beginners, and it has a garbage collector, which means unlike C, developers don't need to worry about manual memory management. Okay, so at this point, we've reached the level of the iceberg where most people are afraid to go any deeper. Things are going to get weird. What happens is that many developers get jaded with these big, heavy, object-oriented languages and go searching for a better way. At this level, we have functional languages, the most famous of which is Haskell. Instead of classes, inheritance, and all kinds of crazy design patterns, the only abstraction you really need is the function. It was inspired by the Miranda language and is named after the mathematician Haskell Curry. Most importantly, variables are immutable and functions have no side effects. Surprisingly, you can build almost anything with these limitations, although most production code out there is not functional. Most of us run into problems when trying to figure out what a monad is, which in layman's terms is just a monoid in the category of n-functors. Haskell is great, but Microsoft developed a functional sister language to C# called F#. Unlike Haskell, which is purely functional, F# is also imperative and object-oriented, making it more approachable to developers coming from higher up in the iceberg. Now, if you hate Java, a good alternative is Scala. Like F#, it supports both object-oriented and functional programming, but it runs on the JVM. It's statically typed, but there's another JVM language called Clojure that is both functional and dynamic. And this makes it more well-suited for getting things done quickly, with the trade-off of type safety. Other popular functional languages include OCaml, which is used extensively at Facebook, and Elixir, which has a very nice Ruby-like syntax and is capable of building high-performance real-time web apps. There's also Elm, which is a purely functional language that compiles to JavaScript, which can build front-end UIs with zero runtime errors. But now it's time to go one level deeper to the heart of the iceberg. These languages are absolute chads. They're low-level systems languages that can manually manage and optimize memory and are used to build things like operating system kernels and compilers that make all the other soy-based languages possible, the most legendary of which is C. It was used to build the Windows, Mac, and Linux operating system kernels, and its curly brace syntax inspired many other languages on this list. Surprisingly, it's not all that hard to learn and has a relatively small set of keywords to memorize. However, being able to use it effectively requires extensive knowledge of algorithms and computer architecture. For example, C doesn't have hash maps or dictionaries, so you'll have to learn how to code up that data structure on your own. C was the perfect programming language when it came out in 1969, but it only supported procedural programming, and eventually developers wanted more. C++ was originally a superset of C designed to extend it with object-oriented programming patterns, like classes and inheritance. Unlike C, it's extremely hard to learn, and provides many opportunities to not only shoot yourself in the foot, but blow your entire leg off. This is a reference to manual handle memory management with pointers, which got that name because they're just as dangerous as pointing a gun at someone. Despite its learning curve, it's an extremely prolific language used to build highly optimized software like game engines, compilers, and so on. C and C++ are still extremely relevant today, but the modern Chad tends to prefer Rust for low-level programming. It doesn't have a garbage collector, but unlike C and C++, it uses a technique called borrow checking instead of pointers for memory management. This makes it much easier to write memory-safe programs and consistently ranks as the most loved language in the world. The languages on this tier are extremely popular, but now we descend further into the modern languages that you probably haven't heard of. First up, we have V, which is a high-performance systems language that feels very similar to Go, but unlike Go, it doesn't use a garbage collector. And unlike Rust, it doesn't do borrow checking, but it can still create memory-safe applications with its own auto-free innovation where the compiler basically cleans everything up. I have no idea how it works, but it looks cool. Another modern replacement for C is Zig. It's designed to simplify low-level programming by eliminating features like macros and metaprogramming, and is very explicit when it comes to memory management. And it can cross-compile C and C++ just like Clang. Zig is not to be confused with Nim, another high-performance language that's very expressive like Python, but is statically typed and interesting